90% of AI startups that fail will blame product market fit. But here's what's actually happening. They built incredible AI. The product works. Customers want it. And then they hit a wall that venture capital literally cannot solve: GPU infrastructure costs. I'm talking about a hidden capex burden so massive that it's quietly reshaping the entire AI economy, killing startup margins and consolidating billions into the hands of three companies: Amazon, Google, and Microsoft. And if you care about AI, whether you're investing in it, building it, or worried about its impact on your job, you need to understand this, because it's the infrastructure layer controlling which AI companies live and which ones disappear. Let's start with the real numbers, because the narrative you're hearing is completely wrong. A typical AI startup pitching series will tell you, our unit economics are great, we're running inference on shared cloud GPUs, our costs are $0.002 per request. Sounds sustainable, right? But here's what they're not telling their investors: those shared GPU costs don't scale linearly. The moment you go from 1,000 daily active users to 10,000, you're not just using 10x the compute. You're buying your own GPUs, you're managing your own infrastructure, you're hiring infrastructure engineers, and suddenly that $0.02 cost becomes $0.15 per request. A Series B AI startup running real production workloads, they're spending $2-5 million per month on GPU infrastructure alone, not software, not people, just the machines and the power to run them. I've seen pitch decks where the entire Series B funding round, $30, $40, $50 million, gets consumed by GPU capex within 18 months, and the company hasn't scaled revenue to match it yet. They're living on venture money while the infrastructure debt just compounds. Here's the pattern interrupt nobody's talking about. An AI company's unit economics don't actually matter anymore. What matters is capex efficiency, how much infrastructure investment you need to support each dollar of revenue, and that ratio is getting worse every quarter, not better. Why? Because GPUs aren't getting cheaper. They're getting more competitive, which means prices are actually stabilizing or rising on the used market. H100s that cost $40,000 2 years ago, still expensive. New architectures, even more expensive, and the throughput gains don't match the cost increases. Meanwhile, hyperscalers have a completely different equation. Amazon, Google, Microsoft, they're not renting GPUs to you at $3 per hour. They're deploying custom silicon, amortizing infrastructure costs across millions of customers, and they're vertically integrated. They own the chips, the data centers, the cloud platform, and the AI products running on top of it. When Microsoft releases an AI copilot, they don't have a separate cost per inference problem. They fold it into Azure. They bundle it with Office 365. The infrastructure cost becomes invisible because it's spread across a user base of hundreds of millions. A startup can't do that. They have to buy GPUs at market rates, depreciate them, manage utilization, and pray they can sell compute or services faster than the hardware decays. Let me give you a concrete example from a company I tracked. Company X raised a $40 million Series B. Incredible AI product, enterprise customers, real traction. 6 months in, they realized if they want to deliver their AI product with the latency and reliability their customers expect, they need to own dedicated GPUs for each major customer. That's not optional, that's table stakes. Dedicated GPU infrastructure for 30 enterprise customers cost them $18 million upfront, plus $2 million per month in operations, cooling, power, and redundancy. Their annual revenue, $12 million. Their capex/revenue ratio, worse than 1:1. They're spending more on hardware than they make in revenue. And this is a company with a working product and real customers. Now you might think, okay, but they'll scale, more customers, same infrastructure. No, because each customer demands their own dedicated capacity, or they are price sensitive and want shared infrastructure, which means unpredictable latency, which means churn. This is the margin compression that nobody wants to discuss publicly, but it's the actual crisis in AI startup economics. Here's the pattern interrupt number 2. The entire AI startup funding model is built on an assumption that's breaking down right now, that cloud infrastructure is a variable cost you can optimize. But inference GPU costs are becoming fixed costs. You buy capacity in bulk, it sits there whether you use it or not, and every month you're burning depreciation and power whether your customers are happy or not. Venture capital loves variable costs. Venture capital hates capex, because venture economics work on margin expansion. You start with negative margins, you scale revenue faster than costs grow, and eventually your margin turns positive and you're profitable. But if your core cost is GPU capex, that equation inverts. You start with massive fixed costs. Revenue growth doesn't reduce those costs. It creates pressure to buy more GPUs. And your margins don't expand, they compress. This is why hyperscalers are winning. Amazon's GPU utilization across AWS is what? 40%? Doesn't matter. They've spread that capex across so many customers and products that even with utilization and efficiency, the per-customer cost is microscopic. A startup can't do that with 30 customers. So here's what's actually happening in the AI economy right now. 1. Startups that need dedicated infrastructure are discovering they can't raise their next round because investors see the capex math and walk away. 2. Startups that try to stay on shared cloud infrastructure are losing to competitors with better latency, which means they lose customers, which means they die anyway. 3. The only viable strategy for capital-efficient startups is to build on top of someone else's infrastructure, meaning they become a feature of Anthropic, OpenAI, or a hyperscaler. They don't become independent companies. 4. The companies that survive are either A. Hyperscalers playing AI natively on their own infrastructure, or B. Startups that found a narrow, low-compute problem that doesn't require GPUs. RAG, fine-tuning, specialized tasks, things that run on CPUs or small GPUs. The rest, they're bleeding out on infrastructure debt. And this has massive implications for where AI money actually goes and who gets displaced by AI. The AI infrastructure consolidation means fewer companies are competing for enterprise AI. Fewer companies means less innovation, higher prices for customers, and a faster adoption rate for AI automation in jobs because the ecosystem is controlled by players who benefit from that automation. If you're worried about AI replacing jobs, you should be paying attention to this infrastructure story because it's determining which AI products actually reach the market and how they get priced. So here's my takeaway. If you're investing in AI startups, don't ask about customer acquisition cost. Ask about infrastructure capex per customer. That's your real metric. If a startup can't tell you how much GPU infrastructure they need to scale to 10x revenue, they're not a serious company. They're a burn rate ticking time bomb. If you're building an AI product, don't optimize for the most powerful model. Optimize for the most capital-efficient model. Can you solve the problem with a smaller model? Can you solve it without GPUs? Can you minimize your capex footprint? That's how you survive. And if you're concerned about AI's impact on work, understand this. The infrastructure dominance of hyperscalers means AI automation is going to be deployed strategically by companies that can afford massive GPU infrastructure. That's Amazon, Google.